Welcome. In this video I'm going to show you how you can analyze a single binary variable using SPSS. I'm using SPSS version 29 and I'll leave a link to this workbook in the description below. To analyze a single binary variable, we first probably want to get a so-called frequency table. I have a separate video with more details on that, but you can do that by running analyze, descriptive statistics, and then frequencies. Already run this once, but reset. The example I'm going to be using is from a very old survey where gender was still just 2 options. You can actually right click and get variable information, and then you can see how things were actually coded. So 1 was female, 2 were male, and 99 were those who skipped this question. You can then click on OK and you will get the same output as I'm going to show you, but I've actually have here the syntax, which I can simply run, and then it actually gives me that same output. We can interpret this output a little bit quickly. It simply is actually showing that 74% were male and 26% were female. So it appears as if there were a lot more males than females, but is this also significantly different? In order for us to find that out, we can run a test. The most common test is probably the one sample binomial test, although in the appendix later I'll show you some alternatives that could also be used. Most likely you want this one sample binomial test. There are a few different ways to actually obtain this, but the most likely is analyze non-parametric test, one sample. Then I have to bring this into view, of course. You usually start all the way over here. I'll reset everything. I'll go for fields. Unfortunately, it by default has all the fields on the right, and I don't want to test all of them, so I'm going to move all of them back. Control A, scroll down for my 7.1, and move that as the only test field. Then I go to settings and I click on customize test and then compare the observed binary probabilities to hypothesized. There are some options here. Of course, I'm going to assume it was 50-50. I'm going to test if it's significantly different from that. Success would be the first category found. I don't really care because there are only 2 categories. Click on OK, click on run, and you will get the same output. I'm going to close this again because again I have the syntax available here, and I can simply run this syntax, and now it shows me all the output. To interpret this output, the only thing we actually are probably most interested in is that asymptotic significance two-sided test. That's the one that you get in the first table over here, and you'll see it here at the bottom, the 0.002. You can actually double click on these and double click again and you get even more decimal places, but usually 3 is more than enough. Now in this case that means it's extremely low, so the probability of having a result as in our sample, or even more extreme, is very low. Usually 0.05 is the threshold, and therefore our assumption about the population that it was 50-50 is probably wrong, so there is a significant difference in the number of males and females. Now after that we probably also want a effect size. There are a few different effect sizes that can be used with a one sample test. Not much has been written about it, but one of them is Cohen's G, which is actually simply the observed proportion. So in my case it was, I think, 26% minus 0.5. If you really don't want to do that calculation, you can actually trick SPSS in doing this. We then go for analyze, compare means, and then we say we want a one sample t-test. I'll again do a reset in there and then look for my 7.1, and I need to fill out the test value, and this is going to be, I had, if you remember, I had 1 was female and 2 was male, and I want to be exactly in between there. So that's going to be, in my case, 1.5. And because I'm in the Netherlands, I'm using a comma to separate, so I should do 1,5. I don't need to see the effects, estimated effect sizes. I can click on OK, and that gives me my next syntax. which I can simply run now. And if I run this, I get here quite some output again, but actually this value over here, the 0.239, that is actually Cohen's G. So we can interpret that by simply having a look here. There is a small table from Cohen himself, so 0.239 would be considered medium. Alright, if you don't like to read from this table, you can actually copy my syntax that I've written here, which simply does that same thing. You can change the value that you found for Cohen G here, run the syntax, and it will spit out that this is a median effect size. And then you actually have all the steps that you need to analyze a one binomial variable. Alternatives for the tests are the Wilson test, for example, and the Wald test. Each of these is available in SPSS. You can actually obtain them by going to analyze, compare means, and then the one sample proportion. Again, a reset, and I go for my 7.1, move it to the right, and here I can then, under tests, I can actually highlight that I want perhaps which one I want. So perhaps also the score and the Wald continuity correction. You can even get also again here the exact binomial test, and perhaps even one with a mid-p adjustment. Again, I'm going to cancel all of this because, as you can already see, I have the script here, and all of them, no matter which one, I'm now looking again at for the p-value, two-sided p, and as you can see, they're all below 0.05. So that's the alternatives. There are actually these Wald and the score test. They are actually approximating the exact binomial test. As alternative effect sizes, one other one is perhaps Cohen's H accent for one sample, which makes it slightly different from the other ones. Now, unfortunately, SPSS doesn't really have a way to actually calculate that one, so I need to use my syntax again. I'll use the sample proportion that I found earlier, my hypothesized value, and then just run this syntax, and it spits out that it's about minus 0.5. Another one is the alternative ratio, which is simply the observed proportion divided by the expected proportion. So again, there's a small syntax in this workbook for you that can simply calculate that. So if you fill that then out and you run the value, it says it's about 0.52. For more interpretations on these, have a look on my website. But I hope this helped in how to analyze a single binary variable using SPSS. Thank you for watching, and see you in the next video.